Welcome. In this session, we will do an example of a function with several critical points, 4 to be precise. This is somewhat involved algebraically in terms of solving the equation. Fortunately, the function is given in factored form, which will make it easy to factor the derivatives in order to find the critical points. The function is x minus 3 times y minus 3 times x plus y minus 3. To find the partial with respect to x, I will think of the factor y minus 3 as a constant, apply the product rule to the remaining two factors, x minus 3 times x plus y minus 3. The first factor is x minus 3, its derivative with respect to x is 1, times the second factor, x plus y minus 3, plus x minus 3 times the derivative of the second factor, x plus y minus 3. Its derivative with respect to x is 1, because y is treated like a constant when we differentiate with respect to x, which means that we get only 0 from the term y as well as from the actual constant term minus 3. Now, if I simplify the expression inside the braces, I can combine the two x's and the two minus 3's. So I get y minus 3 times the quantity 2x plus y minus 6. When we differentiate with respect to y, it's going to go the same way, or we can use symmetry. So the original function, if we switch x and y, the function doesn't change. So if I switch x and y in the partial with respect to x, I will get the partial with respect to y. So the partial with respect to y is x minus 3 times the quantity x plus 2y minus 6. We have to set this equal to 0 and solve for x and y. From the first equation, which is factored, we see that either y equals 3 or 2x plus y minus 6 equals 0. So y will be minus 2x plus 6. We have to try each of these in the second equation and solve for x. If we substitute y equals 3 in the second equation, then it becomes x minus 3 times the quantity x plus 2 times 3 minus 6 equals 0. So plug in 3 for y in here. That's x minus 3 times x equals 0. So x is 3 or x is 0. If x is 3, since we are assuming y is 3, we get the critical point 3, 3. And if x is 0, the critical point 0, 3. The other possibility is that y equals 2x plus 6. Plug that in the second equation. The second factor will be x plus 2 times the quantity minus 2x plus 6 minus 6. We simplify that factor. So I get x minus 4x plus 12 minus 6 for the second factor, or minus 3x plus 6. We can factor out the minus 3, and we get x minus 3 times negative 3 times x minus 2 equals 0. So x is 3 or x is 2. So we started with the assumption that y equals minus 2x plus 6. So if x is 3, y will be minus 2 times 3 plus 6 or 0. That gives us the point 3, 0. If x is 2, y is minus 2 times 2 plus 6, which is 2. That gives us the point 2, 2. So now we have 4 critical points, 3, 3, 0, 3, 3, 0, 2, 2. We are going to analyze it. So we'll start with these derivatives for hx and hy. Find the second derivative and apply the second derivative test. Xx is the derivative of hx, that is this quantity with respect to x. Y minus 3 is treated like a constant because I'm differentiating with respect to x. So hxx will be y minus 3 times the quantity 2. So when I differentiate 2x plus y minus 6 with respect to x, I'll just get 2. Same way hyy will be x minus 3 times 2. For hxy, I can differentiate hx with respect to y. I have to use the product rule. The first factor is y minus 3. Its derivative with respect to y is 1. Plus y minus 3 times the derivative of the second factor, 2x plus y minus 6 with respect to y. And that will be 1 because we treat 2x as if it's a constant when we differentiate with respect to y. And let me simplify this a little bit by combining like terms. I get 2x plus 2y minus 9. So the discriminant hxx hyy minus xy squared is y minus 3 times 2 times x minus 3 times 2 minus square of the quantity 2x plus 2y minus 9. When I have several critical points, I like to arrange my work in a table like this. We'll go through each point, evaluate the discriminant first. If I plug in 3 for x and 3 for y in the discriminant, it is this quantity. I will get some long expression is calculated to get -9. Since it's negative, it's a saddle point. What if I have 0, 3? Again, I get -9 if you do the calculations. That's also a saddle point. So is 3, 0, which you could have figured out by symmetry. Now we come to the fourth, 2, 2. But this time, the discriminant is positive because I get 4 minus 1 squared. Since it's positive, it's a relative extremum. To determine whether it's a relative max or relative min, we have to look at hxx, which is y minus 3 times 2. If x is 2 and y is 2, that will be -2. Since the discriminant is positive but hxx is negative, that's a relative maximum. This concludes this example.